Hey everybody, Brian here from quantlabs.net. I just wanted to go through, guess what, we finally, I think, finished our Karen Super Trader strategy, or I call it that. The idea behind this is to demonstrate the ability to acquire real-world, pretty close to real-time data from IQFeed, feed it through some kind of little strategy, algorithm, or a piece of code in C#. Have some checks or conditions that get triggered, and use a database. I'm using Postgres on top of interacting with the database and then triggering buys and sells for this strategy using Interactive Brokers TWS Trader Workstation. So just want to give you a brief history, just so we know for anybody who's new to all this. If you come to my channel at youtube.com/quantlabs, this is really critical that people get this. I have a series of playlists here. I've added 2 playlists, one on IQFeed, which goes through the entire different ways of using IQFeed. We actually have a demo here from the vendor behind IQFeed, just demonstrating the capabilities of it, the service. So that's what I'm using as a data source. Number 2, under TWS link 2, because I'm using Interactive Brokers as my broker, and interacting with the Trader Workstation or TWS, there's the API, and there's this product called TWS Link 2, which is a wrapper to the Interactive Brokers API. So please go through these playlists to completely understand what I'm doing, because I'm going to be whipping through this pretty fast, and if you don't have a very good understanding of either of these products and tools, this video is not going to be all that helpful to you. Alright, so what do we got running in the background? Now, with IQFeed, I've talked about Queue Collector to house and retrieve data. I've got that running. I've got the actual TWS running in the background. Also got my Postgres running, which is my database. And I'm really focusing on a positions table here. I've talked about it, and it just goes in and updates price information, date, timestamp for both the entry and the exit. And then of course we have Visual Studio. In this case it's Visual Studio 2013. I'll be doing a complete walkthrough of this source code, and that's in C#. Now, there is another project here that you need to be aware of. I'm creating a C++ DLL. Demoed this last night actually to an audience, my meetup groups, and basically this is the C++ that interfaces with TWS Link 2. Okay, I show how to use this, how to create this, and pretty well, again, those playlists under the TWS Link 2 has this information. So that's the background. Now, let's move on. Okay, so knowing what we know, there's a number of moving parts here. Now, I got my Queue Collector set up. I've got my DTN IQFeed running in the background. I also got TWS Link 2 running in the background. I'm just going to break this. And I've talked about that little icon that now disappears. Again, in my video playlist I just highlighted. Alright, so as I said, I'm going to start from the top. I do have another video here on my YouTube channel. This is called Intro to Karen Super Trader with C#. But I'm going to cover part of this video because breaking it up into 2 separate parts, people get confused. So I thought, screw it, I'll just redo the whole thing over again. So if you've seen this, my apologies. But could be a reminder, I don't know. Okay, so let's start running this thing so you can see what's going on. Essentially, I do have code in here that has somewhat the Karen Super Trader strategy working. I'll go through that in a minute. But really what I'm trying to highlight here with quick and dirty code, I'm going to stress that, quick and dirty code, that you can use as a role model to understand how to pull everything together. I call it plumbing. Able to pull in your IQFeed data, whatever you're subscribed to, you can do it through the subscription, no problem. At the other end, we run an algorithm, some kind of strategy, some kind of trading logic, where it'll trigger buys, which are the same as an entry, and a sell, which is your exit. So that's what I'm trying to point out, is that workflow of how they get the data, do something with the data, and then initiate a trade for both the entry and the exit. So I'm going to go through that in a minute. On top of that, I got in the back end a database to handle the positions for position management. You don't really need it, but you may need it for two reasons: for analytics, for risk assessment, risk management, also maybe for position weighting, portfolio optimization. And when you put on these trades, you want to log those trades, because some of the, obviously all the brokers don't have this capability where you can go back and look at a log of trades that your system has done. On top of that, you can use this for reporting purposes, for P&L, profit and loss, that sort of stuff as well. All right, so let's get to it. So as I said, we've got Q Collector here. I've shown this before. We're going to just focus on SPY. It's the only asset we're going to watch and do anything with. On top of that, we've got the interactive brokers running here. All right, so again, I'm just going to space her all out. And we also have, what else did I want to show? Oh, and the database. Okay. Okay, and then we have our database, the positions table, which is sort of, as I've highlighted before in past videos, not very efficient, but it does a job, and it enables other, it makes it more adaptable for other large arbitrage and pair trading, which I plan to do in the future, so that this position table has been designed for that. So it's very inefficient. Again, quick and dirty, that's all we're doing here. Okay, so let me fire up our code. So this is Visual Studio here. This is basically a bunch of breakpoints are in there. And I'm just going to run it first, and I'll walk you through what it's doing. And at the end of the video, I'll go through all the code in this little program here. Okay, so let me just fire it up. Okay, so this is the application it's running. It's just a console app. Now, what it's doing is it's waiting for a file change. I've talked about this in my past videos. I'll show you what it's doing. If you know Q Collector, I'll make a collect a selected item. Basically what this will do is it'll grab the latest tick and then update a file. This process right here is watching for any changes to that file. So as soon as I do a collect, it'll grab the latest tick, add it to the file. This process here will listen to those changes. If it sees a change, which it will grab the latest row or tick, I guess, from the file, process it, and then feed it into this trading logic. So that's what we're doing right now. So what I'm going to do is I'm going to retrieve the latest tick from IQFeed. So you can see it's just made a set. Here's a change to that file. Here's the latest price. And at the same time, I'm fudging it to do and initiate a buy. Okay, under normal circumstances with a strategy, this won't happen. Just due to the fact of, for demonstration purposes, I want to show this, that it does work, that you can make a change or retrieve a file, retrieve data from a file. You can also stream into it, but a lot of my viewers of these videos are very new to programming, so I'm trying to make it as easy as possible. But for more of the advanced people, you could easily stream the data through a message queuing system like a 0MQ, or my other demonstrations I've shown is with Redis. Very possible. Okay, so if you go into my database, that row and all the info get updated into my position table. So if I do a select, you see you got 3 rows. There's another new row that's just been added with that latest changes from the ticks. So it's got the latest price, and it calculates as if it was going to trigger that buy. I'm going to trigger a short stop loss. We're calculating that stop loss at 15%, and it'll just automatically have a target of any on the exit of market data. If it's within this range of the upper short of the upper stop loss or the lower, it'll exit, and that's what we're going to do. And it just updates all the latest info. Some of it's duplicate, but essentially that's what we're kind of doing. And of course, it will retrieve the timestamp and convert it into readable characters as well. Again, you don't need this extra data. It's just for redundant, but it's just there, just again for demonstration purposes. Okay, so we've hit a breakpoint here, and what it's going to do now is I fudged it again for the exit. Now, essentially, I was going to want to break out both the entry code and have a separate program or application that just focuses on the exit. So I wanted to demonstrate 2 separate programs, but with the licensing of this TWS link, I was kind of behooved to merge both the logic for the entry, the logic for the exit in one. So right now you're looking at the close. So it's going to kind of run 2 processes at once, but it's really doing it single-threaded. But if you're knowledgeable enough to know how to work with multi-threading in C#, I highly encourage you to do this. But again, this is for demonstration purposes and just to make it brain dead easy as possible to be able to show you how this works. All right, so what we're doing now on the exit, which is kind of again fudged for demonstration purposes, is we're going to cycle through all these rows that are currently in the position table, okay, and it's going to only look for only those that have the symbol SPY. And you can make more sophisticated queries, but again, just making it real easy. All right, so that's what this does, and it's going to parse out all the columns in those rows. I'm going to show you that and go into more detail in a little bit, but this is our first breakpoint, and what it's going to do now, it's going to do another sell and a buy and close out the position. Okay, when I hit continue, and that's what this method does, close entry. So I'll show you that in greater detail in a second. So it's hit here. We're going to continue, and I think we are now cycling through that data. Okay, which is fine. Oh. Okay. Continuing along, we are now at another breakpoint. So essentially, we are going to cycle through that positions table and do some cool stuff. It'll break at this close entry. Okay, sorry, continue. So if I go into my TB, you'll see it does a sell, and it's going to close out that position. Okay, and that is that. And also the other big change, let me just minimize this. The other big change, I believe, let me just step over this. There's another big change in the database as well, because that's the exit when it does the sell. Okay, so here we have an exit timestamp and the string representation of it, as well as the current market price at the time of that sell on the close or exit. So that's how everything works. So from the database standpoint, we put the position on going entry or entering into the market. We have the market current price, the stop loss at 15%, and the upper and lower target of the current market price. So once we breach that in the logic I'll show you in a minute, is we can exit, which I've just demoed. This is the current market price. Again, we're fudging it, and this is the time of when we sold or exited the market on the timestamp here. All right, so let's take a look at the code. First of all, as I said, we have our DLL. The only real functions that we're using from within the TWS link 2 are really three: register contract, place an order, and close the contract. That's it. It's the only ones we use for in TWS link. Here, using pinvoke, we're calling that DLL, and we define the C++ function externally to define it within C++. We define it here with the parameters so that the C# can have access to it. So this is how it works. We have, this really should be called Karen, but you'll be able to download this from the member quant leech section. So these are some of the variables and objects that we have. I could keep track of a concurrent queue for multi-threading, but I kept it. I think I'm maintaining really a list. We're also using a data set and a data table for just basically a .NET structure to be used and interfaced with the database. So showing you the pinvoke code here, some other objects. Now I'm not really using these, but I just want to show you how you can set them up. With the Karen super trader strategy, we're just using simple Fibonacci and Bollinger bands, so we're not really using this in the current code. I've commented it out actually, again for demonstration purposes, to trigger the demonstration of the sell and buy with interactive brokers, TWS. So I fudged the code to be forced to do those market entries and exits. So here's how we can define those ranges, though, the bands, the upper band and lower band of the Bollinger as well. Let's see here, this is quite a bit. It's about a 300 line program, but I'll go line by line now through this. I'm not even sure if I should go through the main to make it more sensible, or let's try to do that. Okay, so all this code is useless. I've shown you these two functions. We have the pre-allocate, the prices. That's just to set up the queue. So we're watching our concurrent queue, and we're adding the latest prices from the data file that we retrieve, which I showed earlier, this one here from queue collector that updates that file every time a tick comes in. So there's that. And then the next thing is run. Okay, run. Where is run? Okay, here's our run. And essentially, as I said, we're watching a file. So we have our path, the file name, and we're just notifying .NET to watch that file specific to the path. In this case, actually, we're watching any text file in that directory. So it's not specific to a file, it's just the entire directory. And anything it sees that changes, the one we're more focused on is change. We will call this function or method called onChanged. Everything pretty well points to onChanged. You could get rid of all this code, but if you want to do something like in case the file's been created, deleted, or renamed, we can trigger any kind of method we want. So for there, just keep cycling through this until you hit Q on the keyboard and then just quit. Alright, so we've got the main, shown you that before. Okay, so the next function I should show you is the onChange. So when there is a change to a file in this directory, this will get run, onChanged. So let's look for that. Alright, onChanged here. So let's see here, you'll see that this onChange will files C blah 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 has changed. So that's what we're printing out here. And then what we're essentially doing is initializing these objects. I'm sorry, I've shown this before. Grabs the file name. It will parse out the backslash here, and then it's going to start looking for the file name. So if there's a file name, which there will be, of underscore, it will then be able to parse out the file name, which is really your symbol. Okay, so essentially it's going to look in this directory here, C data files ASCII trial, and then it's going to say, oh, we have this file name spy_0.txt has been changed. So here in the file name we parse out this guy, and we're left with just the symbol name, SPY. That's how all this code kind of does. So if our symbol is spy, which it is, essentially we can just do simple stuff of grab our price, yeah, so we're going to retrieve the latest price here in this method. You'll pass it the name of the file, and then once it's got the latest price, it's going to, I think part of that also includes calculating the upper and upper Bollinger, lower Bollinger, and the Fibonacci upper range. So that's just for display purposes. But let me show you this method here called retrieve latest price. So here it is. So here we pass in the file name. We want to read the latest line in that file. I talked about that earlier. There's a parse on tab, and what it's going after is the second index. So if I showed you that file, let me see here. So if I go under C, the ASCII file, C data file, ASCII trial, and this is the file that we're grabbing. And let me just load it up. It's a pretty big file. It takes a bit. It's got over 1 million. But you see everything's been delimited by text. So it's going to go 0, 1, 2. It's going to grab that latest price right there, but at the end, because that's going to read the last line. So we'll grab this one or something similar. Okay. So that's what this does. And then it displays it. So that's what we're displaying here. We talked about grabbing this file has changed. Here's the latest price. And then the range. But we're not using that at all. So knowing that we have the price, let me just figure out what this gets called. Okay, so we know if the file gets changed, left here, grab the latest price. Remember we talked about the concurrent queue? Adds that latest price to the queue. And I'll also add that price to a prices list. So we talked about the latest price, which gets displayed here. And then from there, we want to place an order, the buy. So we got I talked about the unique ID. That's why you want to watch those playlists, because it's very important under the TWS link to playlist. So we'll do a register on the contract of SPY, returns the unique ID, places the order of that unique ID, does a buy, market order 1 quantity or size 1 with the current latest price from that file. Then it will insert all that info into Postgres. So let me just go over that real quick, because I've got a ton of Postgres videos. So what we're passing is we're going to insert on the position. We're inserting price, the stop loss, the unique ID, and the return code, which is the same as an order code or the order ID sent back from TWS. So we're going to keep that in the database. Okay? And that's essentially what we're tracking here in the parameter list. Connecting in the database, those credentials, get the latest time, the current time, instantiate our objects for both the timestamp. We grab the timestamp, so it's done in .NET. Grab the number of ticks as well. Let me just show you what those two are. Within the database here you have this. Those are the number of ticks since I can't remember if it's January 1st, 1970, I think. And this is the character representation of that. So this is stored because that is totally unique. Number of ticks only can be 1 tick on a microsecond level. So that's what they do, called the Unix timestamp, because it's unique in terms of time. All right. So back in the database of the position table, so we know our number of ticks, our character representation. Then we already know our stop loss because it's passed into this method. Grab the string representation of it, and then calculate our upper bound stop loss and our lower stop loss down. Again, this isn't really needed, but just for display purposes. Then we do our massive insert by creating a SQL string with all that data I just talked about. Do an open into the table. Sometimes you may need to do a reset. Do a fill and close. And the fill is basically will fill with the SQL stuff in a nutshell. Okay, so back to our program. All right, and then what we do is we okay, so this is the buy. That would get triggered. This is where it gets kind of wonky. Now, typically, you probably want to run this, if possible, in a separate thread. Have one thread that will process the entries based upon market data, current market data, market price, and then if the buy does get triggered, it will enter into the market with what I just showed you with a buy order into TWS, as well as doing an insert of that data as I just went over in the database. And that was here. Okay, so this would be a second thread. So essentially this would be a second thread running where now you want to basically check on the exit condition. Now I've never shown this before. Up until this point is all redundant. I've shown before, but this is all brand new. So we have something called process position list. Okay, so this position list here is basically it reads, does a select statement on the position list. Okay. Position list is a query, basically a select statement. Now, before I forget, I should make this class static because we only want one process accessing the database at one time. It can corrupt the data. If you saw that there was a break into a second video segment in this video, that's what happened. The data can get corrupted, but if you put a static here, this class will only get run once. So that will prevent any corruption on data, on the entire class that has anything to do with calling Postgres, the database. So we were going to show you the query position. Okay, this is very simple. We're querying the database. We connect into it as before. Open. We do a SQL statement of this. Basically select all on the position table with any rows that have the symbol of SPY. So these two will get selected and displayed into the results set. I'll show you that. So essentially, we make a connection into the database, do a fill on the data set, and then you see here we have that DT, that data table, that's used in the data result set, and then that gets stored, and then we close, and the return type, as you can see, is list data row. So it's going to return the data type of data row of all the rows and all columns and rows that meet this query of SPY. So essentially, theoretically, it'll return all these columns and rows that have the symbol SPY in it. So when that gets returned, let me see here. Okay. So this is where we just left off in the process position list. So as I said, what this really does is it's going in and iterating through all the rows in the position table that have that meet the condition of having a symbol of SPY. So we just showed you that code. So now what we need to do is we need to, because we now have a count, in this case you can see it as it's running, that we have 2 rows that meet that condition of having a symbol of SPY. So what we need to do now is we need to go in and basically, let me just show you here. Yeah, it just got corrupted there. It will parse out the 30-second row, 30-second element, which is essentially one of these columns. 32nd would probably be towards the end, I believe. The strategy, maybe the contact ID, contract ID, and the order ID. Remember, those are the IDs returned from TWS when we put on the position. So when we make a call to TWS and we made calls, let me show you that. Just to jog your memory, it can be pretty daunting, I know. Okay, so remember we put the position on, we do a register of the contract. This is using TWS link 2, which talks to TWS. It will return a unique ID of the unique ID of that contract from within the session of TWS. When we place an order using that UID by market of SPY at the current market price at that time with the unique ID, TWS will return a code, an ID. That is our order ID. So essentially, that's what these two refer to. The contract ID and the order ID. Okay? That's how we track it. Okay? So, knowing that, where am I? Okay, so we're left off here. So, as I said, we did a select into the database position table. We now have a list of data type, DT, and now we're going through that list, that array, and we're pulling out 32, which in this case is a unique ID, and we're also grabbing from that row the order ID as well, again, which is these two right here, TWS, contract ID, and order ID. That's how we get that. Okay. From there, we're going to grab the price and our stop loss. No, I think this is, sorry, we're grabbing our stop loss. Whatever we set in that row, whatever the stop loss is, we'll just, sorry, I meant the price. Sorry about that. And we know somewhere in here we're grabbing our stop loss. So we can calculate our upper stop loss as well. Or, no, that's what we're grabbing. So I'm being lazy here. We're grabbing the upper stop loss here. I mean, I could just, let me just show you what we're grabbing as is right now. We are grabbing the sixth position, 0, 1, 2, 3, 4, 5, 6. So we're grabbing this one right here. I could eliminate these two columns, no problem. Just here, grab the stop loss, and then just do a calculation on this guy. Simple. I could do that. Okay. Knowing that, we're grabbing the upper bound, the stop loss. All right, so we have that, and what we're needing to do now is, because we know we're in an exit, so we're going to do a sell, basically close out the previous buy, and that's where we need the unique ID. Okay, and then we just close it out, and it'll close it. Oh, I'm sorry. Skip this step here. Yeah, so it's going to use the unique ID, the order ID that we retrieve from the database, do a sell, limit, quantity 1, market price, whatever that is, and then we just close out the order. We keep it running if we want to modify or whatever, but in this case we just want to close out that position. Okay, so that's going to close the contract of the unique ID. All right, so now we got to take well, this is redundant code. We don't really need that. Again, we don't need that. We've already calculated the stop loss of the upper. And then here you'll see I've kind of commented it out. But essentially what we could do is we take if the current market price is greater than the stop loss, exit. But again, we're just doing all this code. We're forcing it, fudging it to just close out, just to demonstrate that, this is how you do it. But you put all this code usually in this block for the exit. And then once we know the position's been closed, then we can mark off in Postgres, the database, the position table, to update the proper row, what our current market price is on the exit. So when we close out the position, we want to mark that off in the database. So if you see in this instance, it was closed out 199.57 on today, October 7th at this time. Okay, and here's the Unix timestamp of that as well. Again, We could just take out all this string representation as well, but you know, just visually, just for testing, it's easier. So we've closed out the position, we've updated the database. Where do we update the database? Right here. And what we do is we pause. Just so you know, remember, this is single-threaded. When you do a fill, when you put a position on a buy or sell, you need to allow TWS to basically fill the order. It can take up to 5 seconds, so I just hard code it for now. But there is a TWS link function that is called wait for DLL. Let me just pull that up for you. This is the TWS link batch testing tool. I've shown this in the TWS link playlist, but let me just think here. That's probably, there's an easy way to show this. Yeah, here. I'm just going to pull up the documentation. And patience is a virtue. Where is my trading commander? Here we go. This is what I wanted to show you. I've shown this in my video playlist. I'm showing you the code, or so all the HTML documentation for the wait for this one right here. Wait for filled. So all it really does, the wait for filled, if you just specify your timeout, and it will wait from within TWS link. And then there's certain return codes, but in this case I'm just doing it through regular.net. Alright, so let me see if there's any other code that I have not talked about. So that's pretty well it. From the exit to the entry. Oh yes, I've shown this before. This is the process Fibonacci. Very simple. Takes from the queue, concurrent queue, the minimum and maximum, and it will calculate those ranges I've shown earlier. The Bollinger is very similar. Takes the average of the queue and calculates upper and lower bound. Pre-allocate I showed you, the run I've shown you, and the main I've shown you. Okay, there we go. Let me just show you the Postgres, if there's anything in there I've missed. Close entry we covered. Or I didn't talk about close entry. Boy, oh boy. Okay, let me just pull that up here. Close entry, and here. Close entry. Well, essentially, somewhere in there, the code will call the database, and this is what we call. We have our list string and our market price. This is to mark the database. I gotta find that. It's gonna drive me nuts otherwise. I know roughly where it is. Here we go. Close entry. Okay, so I don't think I showed you this part. Yeah, so in the process position list, we talked about the unique ID, order ID, which we retrieve, do a place order, close a contract, and now what we got to do is convert the list that we retrieved, yeah, I've talked about this, about the short entry stop, how we calculate the stop loss. Here, what we're doing is we're cycling through each column, and we're just adding it to a string list. Right here. That's how that gets defined. So all the columns within that particular row get added to this list string, and we have our market price. So this right here will close out the close entry, which is all it really is. So we have our list string, market price. That's the current market price, I might add. So we do a standard connection in the database, get our current time, shown this code before to get our timestamp, unique timestamp I should add, and we have this monster update. The condition is very simple. Our short symbol that we're only working with the SPY, and that has a unique timestamp that we've already retrieved from earlier, and we know it's only going to grab one, and it's going to update everything with the latest info. And really the only info that gets updated is this exit timestamp, time string representation, and the current price, the market price. That's it. That's the only thing that gets updated to mark the table. And talked about the fill and close out the database. That's it. Hopefully that's pretty simple. That's quite a long video. So I'm going to imagine this is a 45-minute video. So what does this mean? Well, it's a good code base you could kind of work off of in .NET, C# specifically, to model your own system that can retrieve data from IQFeed, real world market data, showing you how to do that. And this is just one method where it's going to listen to that file. And at the same time, under certain conditions, we'll send that over that order with that current price to TWS, as I demoed, on top of being able to maintain and track all the entry price, exit price, and if you want, go right down to logging with your TWS, unique ID and order ID. Unique ID being the contract ID. So you could track all that through the database. So if you don't have any problems with transactions, you have that within your database for any mess ups, maybe at the broker level. That's pretty well it. So hopefully this will help you out. And all the code that you see here is available, as I said, available for my Quant Elite members. As I said, if you got any questions, just shoot me a YouTube comment, usually the best way, or a Facebook message. I'll talk to you later. Have a good one.